Hi, my name is Michael Alexander Trolls. I'm presenting hierarchical distribution of consistency-relevant changes in a collaborative engineering environment. As you know, engineering projects require an orderly coordination of engineering artifacts. An engineering artifact is nothing else but the result or byproduct of an engineer's work, so for example UML designs, code, requirements, specifications, and others. And of course, there are dependencies between these engineering artifacts. So when you change one, others have to change with it. For example, if you change a UML diagram, you have to change their respective code. If you fail to propagate these changes properly, you potentially produce inconsistencies, and inconsistencies you obviously don't want to have because they lead to costly errors and flawed end products. And of course, the bigger a project is, the higher the heterogeneity of artifacts is within that project, and that adds further challenge to this problem. So, the distribution of consistency-relevant changes essentially informs engineers which changes to propagate in order to keep their own engineering artifacts consistent with the rest of the project. So how are we doing this? In our approach, we equip engineering tools with tool adapters, and these tool adapters incrementally synchronize changes on engineering artifacts from within those engineering tools with an artifact storage. And in this artifact storage, these engineering artifacts, respectively changes thereon, are stored in a uniform data representation and within a hierarchy of changes. We'll see that in a second. Of course, every change that is stored in an artifact in the artifact storage causes a change event. This change event is then analyzed by the consistency checker, which is then producing feedback for the tool adapters, respectively the engineers. So I said we are storing changes or artifacts within a hierarchy. So within the artifact storage, you have different work areas, and these work areas are linked together in a hierarchy structure, and every tool synchronizes its changes to one specific work area within that hierarchy. And an artifact then is constructed from the work area, the changes within that work area, and whatever is stored in superordinate work areas above the work area with which the tool is synchronizing its changes. So for example, in tool A, you have this artifact with ID 1. In our work area P, this variant has the value A and the length is 1, but in tool A you have variant B because this is a change from within that tool. That variant B is stored within work area A, and together with work area P, work area A and P construct the perspective of tool A on the artifact storage. The same goes for tool B, but in this case it changes the length. So the variant comes from work area P, and the length is stored in work area B. So when one work area now commits its work to the parent work area, to work area P, the variant B in this case gets updated and also updates the perspective of tool B, which now can see variant B from work area P. And how do we check for consistency in the setup? Essentially what we are doing is we are listening to change events coming from within those work areas, and then we analyze those changes, and whenever a change is related to a certain consistency rule, here as consistency rule definition as CRD, we retrieve that rule and we gather the data necessary for a rule re-evaluation, for example, variant or length from the artifact, right? And then, of course, we write the results back into the respective work area that triggered the consistency check, in this case work area B. So you have the CRE here, the consistency rule evaluation artifact. So that is also an artifact or an artifact change that is recorded in our artifact storage. So now for the distribution of change information and why it is so important, especially within this hierarchy of work areas. Here you have an example for a consistency rule. You have this property L arm upper and this property L gripper, and together those must be more than 1. So imagine this is, for example, some description for a robot arm, right? So L arm upper is the upper part of the arm and L gripper is the front gripping part, right? So from the perspective of work area A, that consistency rule is broken. So the CRE is false because L arm upper 0.75 plus 0.15 is 0.9, so that is less than 1, so that CRE is false. In work area B, on the other hand, L gripper is 0.25 and plus 1, that is 1.25, so that is fine. That CRE is still true. That is the starting situation. However, when work area A now commits its changes, work area B's perspective on the consistency state becomes outdated because L gripper plus L arm upper is exactly 1, not more than 1. So that CRE is no longer true. So what are we doing here essentially is we propagate changes to all sibling work areas and essentially trigger a re-evaluation of the consistency rule from within that work area B here, which is then correctly written as false. And that is how this distribution of change information works. And of course, feedback is then sent back to the engineers. And you can read all about this in our published work, particularly hierarchical distribution of consistency relevant changes in a collaborative engineering environment. And if you have any questions, please let me know. I thank you for your attention.
Thank you very much. Another very interesting talk. And we have Michael here again to respond to any questions. So please, if you have questions, don't hesitate to put them up on the chat window. I mean, a question that is arising in my mind, Michael, is, I mean, could you elaborate on the core benefit? I think I know what it is. And related to that, how realistic it is to achieve this without interrupting engineers' work.
So the core benefit or the main benefit of this work is, of course, having different heterogeneous engineering artifacts from different fields, different domains, and you integrate them in a unified way in an artifact storage where you can analyze those artifacts on base of generic rule set essentially. And then you can give feedback on the relationships or on these rules between that form a relationship between artifacts, of course, back to engineers, and that is essentially done in a way, or is done automatically. And so, for example, if you had UML and if you had code, you don't need to manually compare these things, but they're automatically compared by the consistency checker for you in this environment, and you're automatically notified on any inconsistencies. We try to hide this whole mechanism from the users essentially. We only essentially we give this tool adapter out. The tool adapter is used by the tool. The engineer still works with the tool he or she is used to, and they synchronize the artifacts, and back comes feedback. And we try to keep this as undisruptive as possible, of course. Of course, you will get feedback in a certain way. This has to be implemented in the tool adapter. How the feedback is actually realized, whether it's just a pop-up screen or whether some highlight is given in your tool. But beyond that, we try to not really disrupt the work of the engineer in any way. So yeah.
Yeah, no, that's great. I mean, we have about another minute until we need to start thinking about closing the session. So, I mean, a question I have as well is, and maybe you can use an example in describing this. How difficult is it to implement the various tool adapters?
Essentially, we are trying to simplify this process essentially of implementing tool adapters. Of course, every tool adapter needs to be plug-in for the respective tool. So we provide an API, we provide an interface to our environment, and then on the basis of whatever the tool provides in terms of plugins, for example, tool Eclipse, for example, provides a plugin base from which you can implement plugins. We use in this plugin environment or in this framework, we use our own API, and then basically build a simple tool plugin that can communicate with our artifact storage. And there's one question, I think. What thoughts do you have?
Just to caution, we have
Yeah,
38
yeah. I
seconds.
try. I try. I try. I
Oh,
tried
yeah,
real quick. What
that
thoughts
means
do you
you have
have?
about 10 seconds.
Yeah, regarding either the prevention or repair of inconsistencies at a transactional or process level. I'm not exactly sure what
Okay,
the
Michael, let's
transaction
just
is. Sorry.
continue. We can move, I believe, afterwards to the
Yeah,
open room and
please,
we can take the
please, please,
questions
please.
there, and that would be fantastic. And we hope to see a lot of people there. So we have to close the session now. It's been a good experience online, 4 excellent talks. Thank you very much to all the presenters and the questions received.